Hello, and welcome to MVAO 103, Auto Operator Configuration. This is Part 1. MVAO 103 is the third in an 8-part series of courses designed to cover Auto Operator. Let's begin our discussion by covering MVS subsystems. A subsystem is a service provider that does one or more different things, but it doesn't do anything until it's specifically requested to. Now, subsystem in MVS terms can mean a couple different things, but in this context, we're talking about formal subsystems. And a formal subsystem is either the master scheduler or one of the subsystems that gets started within the IEF SSN member or using the set SSI command or the IEF SSI macro. And there are two different types of subsystems. There's a primary subsystem, which is typically JES, and then there are secondary subsystems, such as the BBISS used by MainView. The MVS Subsystem Interface, or SSI, handles two types of requests. The first type are directed requests, and those are defined by the installation. And the way they are meant to be used is to communicate with a specific subsystem, either to provide information or to request information be returned. And the second type of requests are broadcast requests, and those are defined by the operating system. What it does is it provides the ability for multiple subsystems to be informed when events occur. Now, the way this will behave is the SSI will give control to each of the subsystems in the order in which they're defined in the system, and they can take control of that event. So for instance, you can let a subsystem know when a WTOR message is generated, and then that subsystem can generate a response to that message. Let's take a closer look at how AutoOPERATOR handles messages and commands. The first thing to point out is that the order of your subsystems on the SSI depends on the startup sequence, and JES is typically going to be first, but there are exceptions to that, which we'll talk about in a little bit. So when AutoOPERATOR is handling messages coming in, he will see all of the message for all the systems in the sysplex. What AO will do is he will ignore all of the messages that have the foreign bit set on, so he only processes messages on the local system. One of the most common activities you'll use AutoOPERATOR for is handling MVS messages. And I want to point out where the activity occurs when you're handling these messages. If they're not related to the BBISS, that's to say they don't require BBISS functions or facilities, those activities will occur in the address space that generated the message. And that includes any criterion matching for selection of the automation. If you want to suppress, reword, or reroute the message, that will occur in the originating address space. If you issue MVS commands or TSO notifications, those will also occur in the originating address space. Now, some things will not occur in the originating address space. If you need to write messages to the journal, generate alerts, schedule execs, issue commands that aren't MVS, and set variables, those things have to occur in the BBISS address space. This slide illustrates the processing that would occur when a rule is executed. So you can see over here on the left, we have a space for the originating address space. The first thing that's going to occur, well, you're going to have some event, and then he's going to compare that against any defined selection criteria for the rule. And when he does that, he's going to see what actions are available. If there are actions he can take locally, such as rerouting or rewording messages, then he's going to take those actions in the originating address space. If there are other things, such as setting variables or executing execs, AutoOPERATOR is going to generate a PQE, and that's going to pass the necessary information over to the BBISS, where it will take those actions that need to occur in its address space. Process queue elements, or PQEs, are central to the processing of AutoOPERATOR rules. What they do is allow you to transfer information between address spaces. Most commonly, we're referring to the transfer of information from the address space generating the event to the BBISS subsystem. Now, you will generally have one PQE per automation task, and by that we mean when you need to write data to the journal, generate an alert,
or execute an exec with a command response. Each of those will require a PQE. And the PQEs are generated in extended CSA, but as soon as possible they are copied over to private area in the BBISS and the eCSA is released. If you need more PQEs, you can specify additional ones in the BBISS PARM member in UBB PARM under the parameter max PQE. Special consideration needs to be given to processing JES messages and commands. The problem is that by default, JES will see the messages and commands before AutoOperator, so you can't take any automated responses to them, since by the time AutoOperator sees a command, JES has already issued it. So we do have a way to handle that. In the UBB PARM library, in the BBISSP member, there's a parameter called JES filter. You can set that to cause AutoOperator to see the events before JES does. Now, one caveat here is that if you need to bring down JES, you have to issue a .unhook command to release that JES filter so JES can come back up. And the easiest way to accommodate that is to build a rule in AutoOperator that looks for the JES end message, and when you see it, you just issue the .unhook, and that will accommodate that for you. MVS provides some basic message management facilities via MPF, or the Message Processing Facility. When you have an automation product in-house, such as AutoOperator, the recommendation is to use AutoOperator and not MPF. And you can do that by setting honor MPF equal no in the AAO PRM member. This slide shows the format of a typical SYSLOG record. What I'm going to do is just going to briefly go over these fields in the succeeding slides and talk about them just at a high level. Now, if you want to see how all the fields are mapped out in the SYSLOG records, including the flags, you can look in the sys1 modgen library and you can find the dsect in there for the SYSLOG records. The first field in the syslog record indicates the record type or its purpose. I'm not going to read through all these different options. These really are documented in the IBM documentation, so you should look there if you need additional detail. The second character indicates whether the message is related to command processing. If it's a C, that means it's the input to process the command. If it's an R, it's the response from the command. And if it's an I, that means it's something that was issued internally. The next part of the message will indicate the routing codes 1 through 28. And if you have a multi-line message, then you will also see an identifier for that on each of the subsequent messages. Let's take a closer look at the BBISS architecture. There are limitations to how many subsystems or different targets that can be supported by a single BBISS. Typically what we have is one for each MVS LPAR, and that's to support automation. A lot of customers like to use AutoOperator to manage their IPLs, so it's best to have it segregated from the other AutoOperator functions or solutions. The BBISS can also support a single IMS because of the way that messages are identified in the AOI exit limits that to one message region per BBISS. We can support up to 128 CICS regions, up to 15 DB2s, 15 queue managers, and then 1 NetView sessions. How many BBISSs will you have in your environment? Well, it depends. We do recommend that you keep it to the minimum number possible, although there are situations where you will want to have more than one. Some customers like to break out their BBISSs by function, so they'll have one for CICS, another one for IMS, another one for DB2, another one for MQ. There are also going to be situations where you exceed the architectural limits. So if you have 300 CICS regions, then you're going to need 3 BBISSs to support that. AO for ZOS should run in its own address space. Again, that's meant to handle your IPLs and shutdowns so he can take care of everything else before he shuts himself down. And you will still run AO in your MainView address spaces to do your non-MVS automation, such as your kicks things, your IMS things, DB2, so on and so forth.
Let's consider the pros and cons of having multiple BBISSs on a single system. The advantages are it allows you to isolate your functions, so your CICS capabilities are separate from your DB2 capabilities. It provides you with less exposure in the event of an abend of the BBISS, so you're only impacting one area instead of all areas. And another advantage is you can use the BBISSs to monitor the health of each other. Now, some of the disadvantages are that you have to define VTAM links between your BBISSs even when they're on the same system. It also makes it harder to correlate information between different sources, so you have to pass shared variables and do some more complicated things. Maintenance issues, and then there's also a little bit of additional overhead of running multiple copies of the BBISS code. Now let's take a closer look at the BBISS started task JCL. On the program statement, we can have a couple different values depending on how you set your allow user key CSA set in your sys1 parm member. If you've set that to no, what we're going to want to do is call program SSLoad4 because that will provide some additional storage protection in CSA. If you've got that value set to yes, it probably makes best sense to use SSLoad 8 to put the storage in key 8. Otherwise, you can use SSLoad. There are several values that are specified on the parm statement, and we're going to talk about those now. So the first one is the default for the type of start to have, and that's a warm start, which reuses any control blocks that are out there in CSA. He doesn't reread his parameters. He keeps his alerts, all that stuff. So he really is a warm start. Keeps things pretty much the way they were. If you do a cold start, what will happen is any control blocks that have been obtained will be released. It sometimes happens on its own. When you upgrade MainView, he will detect a cold start as needed, and then he will do a cold start. In those instances, you'll probably get a WTOR that needs to be responded to. Just be cognizant of that. The cold starts also can be requested by just doing a start equals cold. And you can also issue a free on your parm that just releases the control box like a cold start and just comes down. If you do a kill, it removes the BBISS from the system as if it never existed, but it leaves the control blocks allocated. So you really don't want to do that unless you have no other alternative. Now it's very, very important to note, do not cold start your BBISS when you have active terminal sessions. It's always best to go into AutoOPERATOR, do a .d user, and see if there are users connected before you do that recycle with a cold start. The next parm is the SSID for the BBISS address space, and then the one following that is for the vpool. And in vpool, we can say no reset, which leaves the shared variable pool the way it was. If you say reset, then what it causes to happen is AutoOPERATOR will get rid of all those shared variables, and then he'll reread the BBIVAR member in UBBParm to populate any variables that he's supposed to by default. Now, vpool equals reset only applies on cold starts, and it has no impact on your profile variable pool. The next parameter on the parm statement is for the CSM group that's used to initialize the system. A CSM is an older technology that's been replaced by MainView TOM, Total Object Manager. They both have the same type of behaviors to start and stop objects in the system, help you manage your IPLs. CSM is the older version of that. We do still support it, but it's functionally stabilized. You should be looking at using MainView TOM at this point. But I digress. So this value can specify no, which is to say to use the value that is the same as the name of the BBISS subsystem. If we specify yes there, we will issue a WTOR to request the name of the group that you want to use for the initialization. If you specify restore, it will initialize the previous values. Or you can optionally specify an alternate member to use that contains all the group definitions. The BBISS started task JCL has many DDs in it, and I'd like to talk about those now. The first one is the BBI parm, and BBI parm contains all the initialization parameters for AutoOPERATOR, as well as the rule sets that have been defined. The sysproc contains the rex execs and any CLIST procedures that you've defined, BBI Journal 1 and 2 are the journal files or the AO logs. And what they do is contain all the messages from the BBISS, and then additionally any messages that have been generated to the journal via AO rules or execs. Now, the way those get processed is if one of them fills up, there's a proc that's specified in the parms that gets executed to dump and clear the file as processing goes on to the next file. There are also some BBI image 1 and 2 files. They're typically not used, but they're available to you. There are HIS-DS files that are used for your history data, and they're a round-robin type processing. There's no action you need to do to maintain them. You just kind of go around. They do contain all of your automation reporter data, so they can be very handy to maintain. The PARM file is used to dynamically manage your history data sets. BBCFG contains your configuration data, and that will point you to the suffix members for all of your different PARM members that you reference in BBI PARM. BBI vars is your profile variable pool. Those variables will survive IPLs unless you explicitly delete them. The BBI div is your linear data set that holds a lot of different data. You can put your non-volatile alerts in there, any arrays that you may generate from processing. It's a linear data set, and it's also used to pull the data for Automation Reporter. BMC PSWD is your password data set for authorization of your licenses. BB Secure has security members that have been customized. The BBISS also can have many libraries in its step lib. You'll always have the BMC link or the combination of BB-link, DB-link, and XX link in the step lib. If you're running the AutoOPERATOR for CICS solution, then you're going to want the SDFH EXEC library. For IMS, you'll want the ResLib. For MQ, you'll want the auth and the ANLE, and then the TCP libraries. There's also a DSN load DD if you want to process the DB2, and that's the SDSN load library. BBI load points to BB link. There's a BBVDEF, which contains all of your view or display information. There's a BBActDef, which is an action table that's used internally. And then there are your typical dump data sets. And a couple libraries that are very important. The UBB Parm, which contains all of your customized parameters and rule sets, and the UBB Proc, which contains all of your execs and CLISTs. Additional libraries can be generated when you run the MainView CLIST to start your AutoOPERATOR session. You will generate a BBProf dataset which contains your profile, right, your key definitions, any preferences on command line, things like that. It'll also generate a BBI journal dataset, which is used for your local commands. So if you issue commands in the BBI journal, it'll write those to your personal journal. It makes it a little easier to find things if you go back to look for things. There's a BBI image file that really isn't used. It's still there, but most customers don't use it. The same thing with BBIS print. Now, there are two libraries at the bottom here that you will use. That's the BBSDEF and the BBVDEF. The BBSDEF contains any customized screen definitions you built in AutoOPERATOR, and the BBVDEF contains any customized views. There are also some site datasets that are generated to be used by all of the users in your environment. There's an SBBProf that provides some defaults for your profile dataset. It's concatenated after your user level library, so if you've customized things, it takes precedence over what's in the site library. Same thing for the BBSDEF. There's an SBBSDEF that contains any screen definitions that you want to share with all the users, and the same thing for the SBBVDEF. Again, any view definitions you've customized that you want to share with all your MainView users. Some customers choose to implement a non-standard thing for the panels. They build a UBB lib, and what they can do there is they can put help panels to embed behind their alerts. It's not something we do out of the box, so we want to call it out here. What you would do is modify the MainView CLIST to allocate the library in a PNL lib DD.
Here's an example of the C list. You can see in blue we have highlighted key things that you'll want to change. For the SS, what you'll want to do is specify 4 question marks, and that will cause it to use the default that you set in the profile. SS confirm no says don't pop up that screen every time I want to get into MainView. If you say image no, he won't prompt you to allocate an obsolete data set. Same thing with print no. It's another data set that you won't use. And if you want to use the BBP lib to embed help behind your alerts, here's how you would change the code. That concludes MVAO 103 Part 1.